Hi guys, welcome back to this next lesson of our Blender for Production series about 2D and 3D tracking inside of Blender. My name is Helge Maus from Pixeltrain. In the last lesson we finally started with 3D tracking and solving, and I hope I gave you a good fundamental overview about how a solver works. In this lesson now we want to see the whole workflow and the tools which are involved in that. I hope you like it, so let's start immediately by going into the VFX template here. Like always, let's go to Open, into our trainings data, into our footage. And like always, I can remind you that you can use your own footage if you like. If you want to support me here, you can buy this really cheap footage package on my Gumroad, or it's also part of my Patreon, so you'll also find it there. I'm also happy if you work with your own data, but let's get started here. I go into perspective and you remember our snow bridge here. I want now to work with this sequence of that. I used frame number 1 to, let's take a look here, 119 so that it's not too long. And I start now loading this sequence here. Then we go into our color management, make our settings. This footage was made in 30 frames per second, so let's switch that on here. Let's set the scene frames, prefetch, and take a look into that footage now. I see that I have to activate here the playback for the timeline. Here we go. Now you see, I'm walking towards this bridge here, and you will see that the footage is a little bit shaky, but not too much. Now I want to talk with you about the eye of a match-moving artist. What you are now looking for is this shot trackable? Where will problems occur? Which technique you maybe want to go, and so on. This is now something I will do in this and also in the next lessons, that we talk a little bit about how to approach a shot like this here. So the idea is, for example, that I later want to place an object here on the bridge. We see that we don't have a real floor, so here is a little step and the snow is not really equal in the floor sense. So this is a little bit compositing work later, okay. Then the next question really often is, do I use an automatic tracking approach or do I do the manual tracking approach? Blender is much better in the supervised or manual tracking. You have seen that the tracking tools in Blender are made for this. They are really good. In one of the next lessons I will show you the automatic way or the semi-automatic way, but in this we will use here the manual approach. The next thing I now want to take a look into is, do we have parallaxes? This is a really important concept. We talk about this in its own lesson when we talk about nodal shots. You know now what a parallax is. So do we have parallax shifts going on in that? And we see here in these two sides of the bridge, yes, we have parallax. We see this is in the front and it moves here in a different direction than the background here. Also, if we take a look here onto the floor and we compare here elements, you will see that we see the rotation of the whole thing, and some are more in the front than other ones, so that's quite good. Also, another thing I want to discuss here is all these branches here. They give you a lot of features if you like that, but the problem with these branches are that these patterns are really chaotic, so it's quite hard also for you as a manual tracker to keep the feature. Another thing is that we maybe have a little bit of wind, so it's moving, and you remember we don't want to track things which are too far away because this footage is only HD, so maybe the tracker can't really find in the pixel matrix a good feature. So be aware of that. Also, we don't want to track crossing lines from different objects. So we will take trackers here on the floor, but this would be only one plane, which is not enough. You remember I said we have to track in 3 axes always. So some trackers here on the floor, but then we need the Z-axis here, and this could be here the tree. We have some features here on the tree, so this brings us into Z also these two elements, and maybe this here is good for the Z-axis. And that's the way I normally analyze my footage. I hope this helps you in the next lessons more and more to see what you want to do. And we need a minimum of 8 trackers. So let's go back here and make our tracking settings first. We use affine here. We want to normalize the lighting because we have some shadows going on. Maybe this can make a problem later. And in the tracking settings, I want to have a correlation value of 90%. To be sure that we don't track anything close to the border here, we set a margin of 5 pixels here. So that's the setup for that here now. And now we need 8 trackers. One word here, I normally work really slow in the tracking process. I really want to have good trackers which are not sliding at all. In a tutorial like this here, I do this live. Maybe I'm not really 100% accurate with everything, but you have now seen in many lessons before how you track 2D tracks. So be aware of that you can do a much better job at home than maybe I do here now live. So let's search for something. If I have a shot like this here, I want to have trackers which are in the frame the whole time. So these are the best trackers. Long living trackers are always the best. So what I do is I look now on the floor and I scrub here and I see now here features which live for a long time. For example, this thing here lives the whole frame. So I go to the back now, to the end of the whole thing, and then I control click here to set my first tracker. I scale it up, and let's take a look into the tracking world now. Okay. I search for something which I can find later better, maybe this point here. Alt S to check here the search area. I think it's big enough. And now what I do is I press the L key to lock my viewer now onto this tracker. And then I go in, hold down the Option or Alt button, and I go now with my back arrows through this shot. You also can hold down your arrow key, then you see it's really playing while it's tracking. But I want to make sure that this here is really solid. I stop here, I scale it a little bit and adjust it so that I'm really sure that I don't lose it. And then I go now to the end here. Here we go. And then we look here into this window while I'm scrubbing over that. This jump here is because of the change of this pattern here. So I rotated it and scaled it. So that's not the problem, but this looks solid. So Control L for locking it. And this was our first tracker. And now I go through. I do exactly the same thing. I jump now to the back, Shift right. And we say, let's take the next feature here. Let's take this here on the tree. Like I've said, we need 3 axes. So this here on the tree looks good for me. Let's take that here. We can test if we can track it now automatically. Control Shift T for backwards tracking. It run through. Great. And now I'm scrubbing through and test if everything holds. And I think it's good. Control L for locking it. Nice. Then let's take another one on the tree. This point here. This here is in the sun. Maybe the shadow changes. So let's take this guy here. I track forward. Okay. Control L. Control T. Okay, looks good for me. Like I've said, normally I take a little bit more time to do that. And backwards. Okay, I think it's not so bad. Great. Let's take something here on this here. So you see, I try different heights. This is a cross that looks good, so we can use this point here. And we can change here the pattern a little bit. And track forward. Okay, last frame. Nice. Jump back and track backward. Okay. You see, that's the whole process now. We go now through the whole thing. Now we need a little bit of parallax. This here is really close on a plane. Here this is in the same distance. So to have a good parallax, I now search something here in this area. So maybe, let's jump to the back here and take a look. We can use something like that here. This is a crossing of objects, yes, but if I track this point here, it's a real feature. It's really at the same point. So that would work, hopefully. So let's try it. I want to have this white stuff here a little bit more in the frame. Yeah, seems good. Maybe a little bit of sliding, but I think I can live with that for this tutorial. Okay, let's finish it. Run through it and Control L. Now we have something here. Now we need a little bit more on the floor. So what about this guy here? Let's mark it first and take a look to the front and the back. I think this could work. Okay, this was fast. Let's go into the other direction and check it again. What's also a good helper is that if you open here this tracking graph and you select here only selected, you see here the graph. And what I'm also looking here into is if we have really erratic jumps. This really often tells me that we lost something here, but this here looks good. Lock it. Let's take something more in the back. So here maybe, or let's take something here, this one here. Okay, seems fine. Have we lost it before the frame was at the end? Yes, we lost it here, so squeeze out the last frame. Yeah, that was the last frame. And we go back here and go into the other direction. Okay, now we have some tracks and the question is, do we have enough? We know we need 8 trackers. A little helper is here in this tracking dope sheet. I go in here with the home button, so here I have now a list of all the trackers. And what you now see here is how long these trackers are living. You see we have the big advantage that all the trackers live now for the whole shot. It's an easy shot to track, but we have also a background color. And red means we don't have enough information in these frames. This is a good helper here from Blender for you, so that you really can understand what you really need here in a frame. We have not enough, so let's take another object. Let's take, for example, this one. And track this guy. And now you see, while I'm tracking here, you see that these frames are getting green. Now we have 8 trackers here which live in these frames here, and this means this here is solvable, but not that here. So you have to make sure that everything is green for a minimum, because green means yes, it's trackable. Here we lose it, so let's go one back, scale it a little bit and try to finish this guy. Great. Now we have our 8 trackers and let's check now the whole thing. We have some here on the floor. Here we are. We have a little bit here into the height on this side and also on this side. So the Z-axis is good. And the question is, do we have something into the back? That's, like I've said, really important concept that we have all 3 axes. This here is behind this plane here, so this, and this is on the same plane. So this goes a little bit to the back and this goes a little bit to the back. Keep in mind that this can be enough, but sometimes it's not enough. I don't think that this is enough, but I don't want now to have trackers which are offsetted, or I don't want tracks which live shorter than the whole sequence for this lesson. So let's try if we can solve that. So that's the lesson idea here. So let's save this scene into our project files. Okay, this is the bridge, version 1. Okay, and then we go here to the solve now. Okay, we talked about the solving process before, and the first thing we now want to try, so we now recap all the stuff we had talked about, is we try that now Blender is searching for the right keyframes for us. You heard that I don't like it, but let's try it. So tick keyframe here, and now we can solve the whole thing. Let's solve it. Okay, it worked. That's a good thing. You see, our solve error is 0.7, which is under 1. It is not great. For this shot, I think we can do better. I hope for a solve error at the end around 0.3 or something like that, but it somehow works. We have now some more information. You see that here in my graph, which we switched here over, we have now a new graph, which is a blue line, and this blue line here is our solve error. If we make that bigger here, and we zoom a little bit in, here, you now see that this solve error here is not a straight line. You see here on this scaling, we go between 0 and 1, so this is the solve error. We are in the average around 0.7. And you see here in this area, Blender is much more sure that the result is good, the reprojection is better. But at the end here, you see we suddenly jump out of that. We are in a much, much higher solve error. So that's the way you interpret that. For me, this can be now a good sign to look into the problem here if we can solve it somehow. So why is here the whole thing not so good like in the beginning? What can we do for that? One thing would be that we have a bad tracker. If we open now this here, we will see that we have here at the end a funny thing going on. You see that here we have an area which is not inside of the frame. That's something which can happen. I don't understand why this here is. It can happen, but if we go now here, we see we don't use it. So that's okay. That's not the problem here. Another thing is that behind every tracker now, we have the error of the tracker. And what we can do is we can sort this list. If the list is quite long, if you have a longer shot, you can go here on the right side and there's a scroll bar if you go close enough. So this can help you if you have a lot of trackers. There is a scroll bar, but you have to go into the direction where the scroll bar is and then it comes up. Let's sort this list. We have here sorting options and we go here now to the average error. And now everything is sorted. The best tracker is at the top, the baddest tracker is at the end. And we can invert this sorting list. So tracker number 5 is the bad boy. Click it. We are still in the lock mode here of the display. It's now in the frame and you see that here. Let's find it again. We don't want to have this one, is it? Where is it? Here we go. That's the bad boy. Let's check. What's the problem with that? I see, okay, this tracker has absolutely no problem. It's solid. So it doesn't mean if you have a higher track error that this tracker is always bad. It only tells you that the reprojection is not really accurate. So that we maybe have a frame where it drifts, and I hope you can see it in the capturing. You see, that's the position of the 2D tracker and that's the position of the 3D tracker. If you scrub over that, you see sometimes it's closer, sometimes it's more away. And that's the problem for us here. You see at the end it's losing this contact here. Let's look into that. What can we do? One thing would be that we have a problem here with our focal length and also later the distortion of the camera. Let's try that. First things first, let's try to make better keyframes. We use the automatic keyframes. The automatic keyframes used frame 1 and 119, the first and the last frame, because Blender saw, okay, all trackers live all the time here, so I take the biggest parallax shift between these two. We can test that. We can say, let's try 1, and then we see maybe frame 100 has enough parallax shift in relation to 1. Let's try this here. And we have a solve error of 0.7. Solve that. Stays. So it's nearly the same. The values were not bad. We can use the old ones or we can use these here. It's not important. That also was not the problem of this solve error. Let's go now to the camera. If you don't know why we are going here, please refer to the video or the lesson before. We talked about that. I want to have a solve later for a sensor size of a full frame camera. And you remember that the sensor width here of the Blender camera, and also here, is not full frame. The name is a 35mm is full frame, but physically speaking, it's 36mm horizontal. And so I changed that. You can do it here by hand, or you can go here into the presets and tell the system I want to have a full frame camera. And then you see 36mm. This here is not changed at the moment, but if you resolve the whole thing, you will see that now the camera has the 36mm here. It doesn't change anything here because we haven't changed anything. So now comes the focal length. I told you that the focal length is changing the perspective appearance. Wider lenses are deepening space and widening the space. If you go into tele, so into lenses which are higher than 50, you compress space in both directions. This can be a problem. Let's test that. We have 0.7 here. Let's say, what if the focal length was not 24? What if the focal length was a normal lens, which is 50mm? Let's try that. I enter now 50 here and say, solve the camera. And look at that. Interesting. Suddenly, our solve error is dropped down to 0.44. That means our solve is now better. So maybe it was not a tracker. It is the focal length which was so wrong that the points are not moving correctly anymore. We can now try this a little bit more, and with more experience as a match mover, you will find better information about what is a wide shot, what is a tele shot, and so on. But you also can go in here and say, what if it was a 75mm? Test it. You can click here. By the way, there is under Shift S here a Solve Pi menu. You can use that here. Sometimes useful because here is a clear solution. So sometimes you really want to delete the solve because you are not sure that Blender is really working correctly. So you can delete the solve here and then you can solve the camera again. So we have now changed it to 75 and you see, ooh, the solve error is back to bad. 50 was better. Let's try 50 again. Shift S, right. Yeah, it dropped. So lower numbers are better. Let's try 45. Shift S, right. Yeah, we drop more. You see, that's the way you can work. If you are on set normally, you have a protocol or you want to make a protocol. You will see that later. I normally want to shoot a lens grid for every lens which was used. I make a protocol for every scene, which lens was used and also which back and camera we have. But we don't have any information about this shot, so we have to find it. This here is my way of finding it manual. What you also can do is we can ask Blender for that. So we have found good keyframes, we have found a solution which makes sense. Now we can say refine please the focal length here. At the moment 0.36 and 45 was our idea. Let's solve this now with the refined focal length. And now you see Blender is able to drop the solve error even more. Now we have 0.25. That's good. And you see now we have a focal length around 35 millimeters. And I think that's quite close to the lens I used here. You see, it's not always a one-click solution. You really have to find good habits here, how you approach this shot. Okay, what else do we have? We talk about lens distortions later. I want to show it later more explained to you, but what sometimes is also the problem is the optical center. What is the optical center? You see here is the optical center of the lens. These pixels value here are exactly the midpoint of this plate here. So if we have a plate here which is 1920 and you divide that by 2 and also 1080 you divide that by 2, you come out with these values here. In a perfect world, a lens should be always centered, so you have an optical center exactly in the middle. But lenses are not perfect, and so maybe your center is a little bit off, and this can also change the whole thing. So you can try to find the optical center here, and we also can have lens distortion. This is again an ordered list. So you have seen, first I try to solve it without any of these refinements. Then I go into finding a good focal length, which makes the solve better. Then if you really think that the lens has a problem, you can go into the optical center to find that. And the last thing is the lens distortion. This is a lens under 50. You remember in the last lesson I told you that normally we go into a lens workflow, or you have to go into a lens workflow if you are under 50. So this is under 50. This is a wider lens. So let's try that. The lens distortion is here, and it's normally calculated in different ways. You see, there's a whole bunch of different models. Blender is using this polynomial. If I later want to use the lens distortion outside of Blender, because I don't want to comp in Blender, I want to comp in Nuke, for example, and so on, I can switch that here, so the values are then recalculated. And you see, Nuke is only using K1 and K2, and I can use these values then in Nuke if I like that. So you can switch that. But I go back here now, and I say, okay, the focal length is found. I can deactivate that now because I don't want to recalculate the focal length anymore. But what I can do is I want to have the distortion here. So let's try to find that. And you see, we are even better here. The lens distortion mostly changes in these border areas of the plate, and we have trackers which are moving really close here. So that's the thing which happens here. To see what this here is doing, we can switch here our view for a moment. This here is still the original plate. If you want to see how this footage looks undistorted without any lens distortion, using these values, you can go here into the clip display, and here you find render undistorted. And the moment you do that, you see that the plate now changes. And you see the plate is shrinking a little bit. Yes, it looks a little bit better. This here is more straight now. And that's the reason why we need normally a good lens distortion workflow for our tracking and compositing work. I think that's a little bit too far for us at the moment. So I go here and say we don't want to use that here now, but I wanted to show you how this here works. So now we have our camera solve. If you deactivate that, these values stay here. So if you now solve that, you see it stays. And we have a solve error of 0.22. That's great. Remember where we started. Now we want to use this shot for something. Let's do that now. We talked in the last lesson about setting up orientation, a camera, and so on. You remember I went to the camera and I then went here to the constraints, make a camera solve a constraint. We saw the points and so on. So if you are interested in that, please refer to the last lesson. Now we want to do it more automatically. For this, we have in the Solve tab here a Scene Setup section with 2 buttons. Set as background sets the background image displayed here into the camera. You see this here is the camera view at the moment. Let's switch this here also to a 3D view. Press the 0 key on the keyboard so that you can see now through the camera here. That's great. And now we can go in here and say we can make this here background of the camera. What we also can do is, and this is the way I now go, is I set up a full tracking scene here. One thing which is now important is it not only builds 3D objects here, it also adds you here render layers. You see at the moment we only have one view layer here, and it also sets up a compositing world here. The compositor at the moment is empty, we don't have use nodes active and so on. But in the moment you click here, set up tracking scene, you will see we have now 2 render layers, foreground, background. We have now a compositing setup here, which we talk about in a moment. And we also now have our objects in the scene. So that's the magic of this button here. That's really great. We will change a little bit of that here in a moment, but that's it. So let's save this scene here. And in now my second part, I want to adjust now the whole thing. Okay, let's set up this scene a little bit easier here. What I want to do, you see here that the cube is sitting in the floor again, like always. So select the cube, G key for grab, Z for Z direction 1. So now we have this cube sitting here on the floor. What we also want to do here in the viewport is we go here to the viewport overlays. Camera path and motion tracking is active because we use these scene setups buttons, but we also can activate here our tracker names for a moment. So you see this is our bunch of trackers which we have here, and you see they are really far away from the things we are doing here. So that's not the thing we are after. Let's activate here the tracker names also. Let's make a coordinate system here. And I want to do it here with the help of Blender. The first things I want to do is I want to define a floor. So I think these 3 points here are good for the floor. And now comes an interesting part. The last point you select, you need 3 points for setting a floor, will be the origin. So what we can do now here is we say, let's say this here should be the origin. I select so this point, shift click this point, shift click this point, click here to floor, and now you see that this tracker here is now sitting. Let's go here to info so that you can see tracker number 7 here is now in the center as the origin. So that's the first step we do. Another thing we maybe want to do is, let's say we want to have a little bit of an axis going on. Let's go here to Z and take a look here. We want to have, for example, if this here is the origin, let's say that this here maybe is then the y-axis. One side note here, this set x-axis and set y-axis is also a toggle. So if you click it again, you will see that the camera is changing the orientation. Sometimes this is useful if you say this here is the axis I want to have, but the objects are on the wrong side then. So you can click it more than once to rotate the y. It's still y, it's positive y and negative y. This is okay for me. We also can talk about scale. So this cube here is normally 2 meters. Maybe the distance between this point here and this point here. Let's say this here is 1.5 meters. So set the scale. So now the points are a little bit farther away from each other. So these are the things you can do with the help of that here. And if you change anything, you can do it again. That's the cool thing. Okay. Now, let's go here into full screen for that and go to Z wireframe. Sometimes you come now to a point where you say, yeah, these were the trackers which I used for Solve, but you are missing helper trackers. For example, you need a position to better tell the system what the floor is. Like I've said, the snow is not even. Or you want to know where a tree now is, or something like that. To do that, we can use the tracking system again. but this time a little bit different. So let's talk about that. I see that the floor here is not really even. The reason can be that this here is good on the position where I want to have the cube, but for example, this here is on a slope which goes down, and then the floor is not even. So what we can do now here is we can say, yeah, I want to have helpers now. For example, this guy here would be a good helper for this point here. So this here is on my preferred floor. So let's go to the last frame and I click that here. Now comes the thing. I have to track this point. First 2D track. So let's do that. Should be easy. It's not important that it lives now the whole way. I will do that so that we can see it later better, but it's absolutely not important. It only needs some time so that the solver later can do something. But this tracker here, this tracker 8 now here, I don't want that this is part of the solve. So I don't want to destroy my good solve, because maybe this is now a feature which is not so good or doesn't live long enough. It's only a helper for me. What you now can do is we can go here to the track, and first I name it helper underscore floor, so that we later know why we have this tracker. And what we then can do is we can set the weight. I demonstrate that really fast for you. I save here only to be sure. I click here on solve, and you will see maybe that our solve error goes up. In our case, not great. This tracker is good. But sometimes the solve error goes now up because this is a really bad tracker. What we can do instead, so Command Z, is I go here and say I set the weight here to 0. This is the weight, how much of this result of this tracker is used for the solve. If I now solve, I have to solve so that Blender makes a 3D point out of that, but it doesn't use it for the result of the solve. So let's solve that again. You will see that the average error is not a number NaN, because it doesn't reproject, it only generates this point in 3D space. What I normally do is I recolor these points. We can have here in the trackers, you see, at the moment, this tracker here, this is helper floor, looks the same like all of these. But what you can do now here is you can tick this little tick box here, and then you have a color field here. So what I do now here is I go into this color field and I set red, for example, as a color. My helper is now red. If we want to have later more helpers, then you can go here into the presets and save here the preset by giving it a name and plus it here. You see, I have a helper preset. So I click here helper, and so the color is now set here. This is now my floor helper, and maybe we want to do the same thing, lock it again, because I say I want to have this point, and this point here for the floor. This is now the example for that. So let's take this point here, and I place it, track it backward. Hopefully it goes well. Okay, this was fast. Check it. Yeah, great. I say this is a helper. It's red now. And I set the weight to 0, so it doesn't bring anything into the equation. This is another helper, floor 2 or B. And then we have to solve again. You see, the solve error doesn't change, but we have now 2 of these helpers here. And what I now do is I go back here to my number 7 and I say this is the track which I want to use as an origin. And now I say I want to have the helper, another helper, and this here on the floor. Now we see we have a better floor which really uses these 3 points here. That's the whole idea behind that. I hope this makes sense for you. Okay, meanwhile the tutorial is quite long, so I think I will close now this tutorial for this week. I will finish with a technique which I use really often to check if this track is solid enough to go into the compositing stage, which we then do in the next lesson. To do that, I want to have a play blast with some helpers. There are different techniques which you can use here. One quite easy one is I place some objects at the areas where I think that the most problems will be, or where you want to place your object. Let's say this cube here has to be placed here, and this is the important position where you later want to insert your stuff. For this, I think I have to make this cube a little bit smaller. You see it's quite big. Meanwhile, I deactivated here the floor because I don't want to see it. I deactivated also here the marker names so that I have this nice and tidy. Select here the cube, go into the edit mode, select the face which is here on the bottom, and with Shift S you can set your cursor to the selected object, in our case the face. Tap then to go out of the edit mode, and then under object set origin, I set now my origin to this selected face where the 3D cursor sits, and then I can press the S key and scale now this cube down until it fits here in my scene. If you want, you can press R and Z here to rotate this guy here a little bit around. Sometimes I use more than one object here. You can copy it around, but in my case, this position here is quite good. What I do next here is I make now this window here a little bit bigger. And what you can do in Blender quite easily here, you find in the view menu here a viewport render. And so you get exactly what's in the viewport. That's the reason why I deactivated the floor and things like that. I think that the trackers here are quite good so that we see a little bit what's going on. And here, like I've said, this here. You can have this here also in solid, or we can go into X-ray mode. But in my case, I want to see if I have sliding. And so I really want to see here the whole thing directly in the viewport. What you also can do is if you select the camera here, go to the background image here. You can change, if you want, the opacity here to make this more obvious what you see here. Okay, that's it. Now we can take that here. One thing which I see now here is we get this little artifact here. And this is not a bug. This is a problem of our workflow at the moment. You remember that I showed you how to calculate the lens distortion here. If you do lens distortion corrections, you have to activate it here then, that you see it. You see this plate is shrinking because the lens distortion is now removed, and you get this same artifact here. And you see that the Blender viewport here uses now this undistorted plate. And it's not driven by this here. This is something you have to keep in mind. But what I want to do, because we don't have the right workflow yet, I can go in here and deactivate that. You can do that here in the camera settings. You remember here are the camera settings values and you can zero them out. Then you have the original plate again, but keep in mind that you then also get the mismatch of the trackers, because the trackers are now calculated with the lens distortion correction. So this is something you have to keep in mind. That's the reason why you see it here. I say it's okay for me. I want to see it like this. I normally make later a test with the composite where I use the right nodes. You can see here, if you go to the compositing setup, you see there's an undistortion node inside of the compositor which uses these undistort values to undistort the plate. But we talk about lens distortions in a later lesson. So that's the reason why we see this little artifact here. Everything is set here now. And go here now to view and say viewport render animation. And this is now quite fast because it's only viewport. So you can tell now exactly what you want to see and so on. One thing which is distracting for people who are new to that is that you don't have any occlusions. Later you normally need the occlusions here so that this here is in front of that. This is something we do in the next lesson with the help of rotoscoping inside the compositing. But here I only want to check. Animation is rendered, great. You can now see the animation by going here to the render menu and say view animation. Normally, now the animation player of Blender opens. I don't like it too much. It's absolutely okay, but I want to scrub and make stills and things like that. So what you can do is you can go here into your Blender preferences, and under file paths, there is a section applications, and here you can set your animation player. So I set my animation player here to custom because I'm a Mac user. Our applications have a package and you have to find the executable inside of the package. If you're on PC, I think it's absolutely enough to select here your player. I normally use for my visual effects work DJV, which is a free player which you find in the internet. You can download it for free and install it. It's great. And I select here custom, and you see my path goes into the application package here to the executable which is inside of this package. And the cool thing with that is now that I can go here to render, and if I now click view animation, I start here my external frame application, which is here, and now I can play here the sequence. And like I've said, you can see it now here in different speeds. You can scrub here around, you have stills and things like that. And I now check here for sliding, and the interesting part here in the sliding, like I've said, this here is normally occluded. This is something you have to abstract, is here on the snow, if it now is fitting, and I think it fits quite well here for the fast setup which we did. So that's the end for today. I hope you learned something useful for your production. If you have any questions, please let me know in the comments below. If you like this tutorial and you want to see more, please subscribe, give me a thumbs up, share it. If you want, you can be a Patreon of mine or get the footage package on my Gumroad as a thank you. See you next time, your Helge Maus.